Working on a project to put an Eggtimer Quantum, which is a Wi-Fi enabled altimeter, into my hauler rocket. So that's a 33 millimeter body tube, it's a 3D printed front assembly, and a 24 millimeter motor mount. So it's basically a way to run experiments. And so, one configuration I can fly is I have a two-piece nose cone. I can put that directly in the hauler and fly it. Generally I do that with a streamer because it goes pretty high on a decent motor. But I added a section using a piece of 33 millimeter tube to put the altimeter in, and this was sort of, well, is my Proto 1. So I'm kind of going to walk through it backwards. So I did a twist lock in it. It's a bit wonky. Sorry about that. And but basically it's the same kind of four-prong locking mechanism that I use for motor retainers. And then it's actually a two-piece print. I couldn't figure out a way to print the whole thing, but I ended up printing the bottom half up and the top half down, and using some nylon M3 screws that work pretty good if you just kind of tap the hole with a regular tap to hold the two pieces together. The Quantum is sitting here and is really kind of tucked down into the bottom here, the shoulder that goes into the body tube. The battery's behind it, and the battery's a bit of a challenge since it's Wi-Fi enabled. It needs, it's kind of power hungry, and so I used this 450 milliamp hour battery. It's a 2S, which means two cells in series to get you 7.4 volts, which then comes along with, well, you got to charge them individually, so a much bigger connector. This particular one has one nice thing about it, which it comes with a JST and a PH connector. So batteries, kind of tough to find. There's tons of options out there, but trying to find one that works well for your particular application is kind of a pain. But this came in a two-piece. There's one tucked behind it. The nice thing is when it's all assembled, I can still charge it, right? Since that connector kind of just tucks in the front. And then for the charges, what I used was something from Perfect Flight. And they posted a sort of instruction sheet on how to use incandescent lamps. And I talked about this in my EasyDD videos. These sometimes are hard to find because of LEDs, but I got this pack at Hobby Lobby to test my EasyDD, and now I've used it for this one, and they're relatively cheap. It was in the floral department, so you can even get them not on holiday hours. But based on Perfect Flight's instructions, I kind of adapted that a little bit. Instead of using silicone tube, I printed a little collar. So I printed a collar, glued it on, and just like this, you can use it to test. And obviously, you need to be very safe with this and follow their instructions. But you break off the glass piece. You're making sure you capture the pieces and wear safety goggles and things like that. And then glue on a little funnel is what I made instead of using heat shrink tubing. This one's a little bigger. And I did 4 of those, and I'll post the video of the ground test in the first flight, and they seem to work well. And the nice thing is, in addition to being able to test it, you can prepare these different charge amounts, etc. I just glued the socket in. So this is the main charge. So you put it in and check the continuity. Please don't use your fingers. Please use pliers. For the apogee charge, it's a little bit more of a debate, and I haven't really figured out exactly what I'm going to do here. In a large body tube rocket, obviously you've got a couple things going for you. One is, you're likely not going to take up the full volume with your streamer or your drogue chute, and so you can just pop it out. The other thing is because the diameter is bigger, right, the chamber pressure is going to exert more force on it, and you really kind of can imagine, okay, any kind of charge going off inside that is going to pressurize that chamber, push the eBay assembly out, and then that's going to drag the chute out with it. Here, one of the things I was actually considering was putting the charge below the streamer, so it kind of blows the streamer out too. After talking with some people at the launch, I decided not to do that. So I kind of wound it up and put it in here for both the deployment test as well as the first flight. And so kind of in summary, I'll tell you what happened on the deployment test. I used 0.4 grams of powder here. It seemed to work pretty well, and 0.25 on the front since the volume is much smaller up there. That also seemed to work pretty well. The flight didn't work all that well. What happened was I flew it on a D12.7, which is underpowered, and what happened was the apogee charge went off, and that worked. Very, very shortly, I believe in the video, afterward the rocket motor charge fired, and that was intentional kind of as a backup. But then also I didn't get the altitude that I had simulated, and so the main went off too. So all three charges go off probably within a second of one another, and everything tangled up and became a hot mess. So got some work to do. This was the first proto, so at least I've got some data. The charges I think worked pretty well. The whole idea of how I'm going to kind of keep everything from tangling and getting complicated, I'll revisit for Proto 2.
3, 2, 1, launch!
That was the motor, I think. I don't know, shoots out.